Alright guys, today I'm going to go through a Madas maths paper. This paper follows the AS edexcel spec. So if you're near the end of year 12 or you're in year 13 trying to revise year 12 topics, then this is the paper I'd recommend. Now these papers are quite challenging, so they're around A to A-star territory. So if you can't do all of them, then don't feel scared or anything, because they are really challenging. Okay? The straight line L2 has gradient 1/3 and passes through the point 0,5. Point D is the intersection of L1 and L2. Show that the length of AD is k root 5, where k is an integer. Okay, now essentially what this means is there's one line called L1 and there's another line L2, like this. Okay, now actually my graph, now that I'm looking at these points, might be a bit wrong. So L1, I think it's better if I switch these two out actually. Okay, so L1 passes through the points 320 and 13, 0. So let's just say that's somewhere around here. And then L2 passes through the point 0,5. So let's just say that's somewhere around here. 0,5. Okay. Now this point D is the intersection, and essentially they're saying that this distance is k root 5. So we need to find out what k is. Now to do this, we need to find out the equations of both these lines. So I'm going to work out what L1 is first. So to do that, we need to work out the gradient. So we have these 2 points, and we can use that to find the gradient. So do the change in y divided by the change in x. Okay, now that we have our gradient, we can sub this into the formula to work out a straight line. So this is our formula, and I'm just going to plug in the coordinates. And now I've just got to rearrange this. Okay, so this is the equation of line 1. Now line 2 has a gradient of 1/3 and passes through the point 0,5. Okay, so straight away with that information, we can write down the equation of that line. Okay, so this is our equation for line 2. And the way I got that is that the gradient is 1/3, like they said. And the y-intercept is 5. Now all I have to do is equate them to each other so that I can solve for x. Okay, so now that I've got x, I can sub that into one of these equations. I'm going to sub it into this equation so that I can get the y-coordinate. Okay, and now I've got the coordinate of D, which is 9, 8. And I've got that, just to remind you, from that and that. Okay? So now that I've got the coordinate of D, I can find out the length of AD. So if I write down the coordinates here, so A is 320 and D is 9, 8. So now I just need to sub this into the equation to find the distance of 2 points. Okay, so this is our formula for the distance between 2 points. So I just need to sub in these coordinates into this formula. And I get 6 root 5, which means k is equal to 6. For question 2, they've told us that the figure above shows a quadratic curve and a straight line with the respective equations. Y equals 4 minus x squared and y equals 2. Okay, so the points A and B are the points of intersection between the quadratic curve and the straight line. Find the coordinates of A and B. So to solve A and B, I need to do 4 minus x squared, minus x squared equals 2. Okay? And next I need to solve for x. So I'm going to bring the 2 to the other side, and I get minus x squared minus x plus 2 equals 0. And now I've got a quadratic, so I can just type that into my quadratic solver, and I get... Now I know the y-coordinate of both of these points is 2. Okay, because it crosses when y equals 2. Which is that and that. Okay, so my coordinates are,
So that's part A done.
part B, I had to determine the exact area of the finite region between the quadratic curve and the straight line, shown shaded in the figure above. Okay, so for this, if I was to integrate the curve, I would get all of this area, right? But I don't want all of that area, okay? I just want this one, this area over here. So what I can do is I can integrate this area, this whole area, and then I can subtract this area over here. And then I'm just left with this area. So if you want a visual demonstration of that, what I'm doing is I'm working out this whole area, I'm taking away this area, and I'm left with just this area. Okay, so firstly, to work out the total area, I'm going to integrate the curve between A and B. Okay, so when I do that, I get this, and now I've got to integrate it, so I get this, and now all I have to do is sub in the values. Now if I type this all into my calculator, I get, okay, so this represents this whole area up here. Now we've got to work out the area of the rectangle. So we know this point here is -2, this point here is 1. So this whole length is 3. And then we've got to do base times height. So we know the height is 2 because it's when y equals 2. So the length's 3, the height's 2. So then we do 3 times 2 to get 6. So now this area here we know is 6. Now we do 21 over 2 minus 6. And we get 9 over 2. Okay, for question 3, we have a circle C with center at the point P and radius R. This has the equation x squared minus 8x plus y squared minus 2y equals 0. For part A, we need to find the value of R and the coordinates of the center P. So to work out the radius and the center, we need the circle in the form x minus a squared plus y minus b squared equals r squared. Now to get into this form, all we need to do is complete the formula for the x's and complete the formula for the y's. Okay, so if we start on the x's first, so completing the square on x squared minus 8x, we get x minus 4 squared minus 16 plus, and I'm going to do the y bits, so we get y minus 1 squared minus 1, and this all equals 0. So I'm just going to underline it to make it as clear as possible. So the underlined bits are all equal to each other. So the blues are both equal and the purples are both equal. Now I'm going to bring over to the other side the 16 and the 1. So we get, and from here we can work out that our center is 4, 1, and that stems from this 4 here and this 1 here, and our radius is root 17. Okay, and that's because this is equal to r squared. For part B, we need to determine the coordinates of the points where the circle C meets the coordinate axis. Basically, it means when does it cross x equals 0 and when does it cross y equals 0. For this, personally, I think subbing it into here is easier. So if we let x equal 0, we get, so y squared minus 2y equals 0, and then y equals 0 and y equals 2, right? and then if we let y equals 0, we get, and then we get 8, then we get x squared minus 8x equals 0, x equals 0, x equals 8. So now we can work out the coordinates. So this whole side is x equals 0, so we get 0, 0, and 0, 2. And then this side is y equals 0, so we get 0, 0, and 8, 0. Alright. Okay. Now on to part C. The points A, B, and Q lie on C. The straight line AB is the diameter of the circle, so that PQ is perpendicular to AB. Calculate the coordinates of AB. Alright, so to do this, I think a diagram is really helpful. And for most circle questions, when it gets kind of complicated, it's best to draw a diagram. So the point Q is at 8, 2, so that's somewhere around here. The point P is the center, and we know it's at 4, 1, alright? So that's about here. Okay, so we know that the line that we're interested in, the diameter, in fact, is perpendicular, so it's like something like this. Okay. Now, if we work out the gradient of this line here, okay, now this line's possible because we know the two coordinates, so we can work out the gradient of this, and from that we can work out the gradient of this. Okay, so I'm going to do that now. So the gradient of PQ is, and this means that the gradient of AB is minus 4 because it's a negative reciprocal. Now that we have the gradient, we can work out the equation of the line because it goes through P. So we get, right, and I'm going to rearrange this to get, now that we have this equation, we can sub that in to our equation of the circle. So you can choose either this equation or this equation. I'm going to choose the circle equation, this one here, okay? So we get, right, and this equation here tells us where the straight line and the circle intersect. Now all I've got to do is solve this equation. Now I've spotted something that it would help us, okay? It's a bit quicker, so instead of expanding and simplifying everything, what I can do is, I've noticed that this is a multiple of this. So it's, this times minus 4 gets us this. So what I can do is do x minus 4 squared plus, and now take out a factor of minus 4 squared, x minus 4 squared, and that gets us 17. Okay, and now we have x minus 4 squared plus 16 x minus 4 squared equals 17. If we add these two up, we get 17 x minus 4 squared equals 17. Divide by 17, we get x minus 4 squared equals 1. X minus 4 equals minus 1. X minus 4 equals 1. And then x equals 3. X equals 5. Now if I sub in these values of x into this equation, we get, so our coordinates are 3, 5, and 5 minus 3. Alright, for question 4, we have f of x, and it's defined as 2x squared plus ax squared plus bx plus c. Alright, and when we're given the information that f of 2 equals f of minus 1, which are both equal to 0, and also f of 1 equals minus 14. And we need to work out the values of a, b, and c. Now straight away when I see that, I'm thinking to myself, I need to work out 3 equations because we have 3 letters that we need to work out. And also they've given us, so f of 2 equals something, so that's one equation. F of minus 1 equals something, that's another equation. And f of 1 equals something, so that's a third equation. So that's how we get our 3 equations. So I'm going to sub in each of these individual letters for x and get my 3 equations. Alright, so here's our 3 equations after we sub everything in. Now I just need to simplify these equations, so I'm going to do that now. Okay, now that we have our 3 equations, I can just put these into the equation solver in the calculator, and I get, okay, so that's our answer to part A. For part B, we need to sketch the graph of f of x. The sketch must include any points where the graph of f of x meets the coordinate axis. Now, we've got, to begin with, we've got 2 roots, okay? Because we have f of 2 and f of minus 1 equals 0, okay? And when f of x equals 0, that's the roots. So we know 2, 0 is a root, and minus 1, 0 is a root. But this is a cubic, so we know we might have another root. It's very likely. So instead of solving this, since it's just asking for a sketch, I'm just going to type in the cubic into the calculator and solve the third, get the third root from the calculator, and I get the third root as x equals minus 2.5. So the third root is minus 2.5, 0. Okay? Now, you need to think of the general shape of a cubic. So if the coefficient of this term, x cubed, if it's positive, it starts off like this. If it's negative, it starts off like this. Okay? So since it's positive, it's going to be something like this, with 2 turning points. Okay? And we know the y-intercept is going to be our c here, so 10, minus 10. So I'm just going to draw the axes. So minus 10 is our thing, is a y-intercept. Our roots are 2, minus 1, and minus 2.5. Okay, like I said, it starts off here, goes up, down. Okay, they haven't said anything about minimum maximum points, so I think we're good there. Just know it's normally in the middle of the roots, so that's just where I'm going to draw it. So we have it like that. Comes down to minus 10 and then turns, yeah, and then goes up like that. Okay, so that's what our graph looks like, and that's part B done. For part 5, I need to solve the following trigonometric equation in the range given. So that's the range minus 90 and 90, and to solve this equation, I'm going to split up the fraction first, so that I get 5 cos 2x over 3 sin 2x plus sin 2x over 3 sin 2x equals 7. And then this here is equal to 5 over 3 cot 2x, right, because cos over sine, and plus 1/3, and that equals 7. Now I'm going to times both sides by 3, so that I get, and then 5 cot 2x equals 20. Cot 2x equals 4. And then I'm going to write that as, and then I can rewrite this as, now that I've got this, so x we said was in the range minus 90 to 90. Was that okay? Like that. So to work out 2x, I can be in the range of 180 and minus 180. Right? So 2x, if I do the inverse of tan minus 1/4, sorry, just a quarter, I get 2x is equal to, and then x is equal to, right, and they haven't given us a certain amount of decimal places to write the answers to, so I've just written it up to 3 decimal places. So that's part 5 done. Alright, so for question 6, we have the cubic x cubed minus 4x plus 1 equals 0. The above cubic has the 3 real roots x1, x2 and x3. Use transformation arguments to find in a simplified form another cubic equation whose roots are x plus 1, x plus 2 and x plus 3. Now if you do further maths, you would have learnt a way to do this which is easier, and you're welcome to use that if you want. What we do is a similar thing to what we do in further maths, but it's more conceptual, so you have to think about it. Now if we were to draw a graph and then just write 3 random roots like this, okay, what we're saying is that we've moved it by 1 unit, okay, like this, okay. So then if this is x, this is x plus 1, and oh wait, sorry, x1 plus 1, x1, okay. And if this is the case, then we've gone to the right by 1, right? So that means we've done a transformation of minus 1, 0. And to represent this transformation in terms of f of x, it's basically just f of x minus 1, and technically plus 0, but we don't need to write that plus 0. And that gets us x minus 1 cubed minus 4x minus 1 plus 1 equals 0. And I just expand and simplify this to get, alright, so our final answer is this cubic here. Okay? Alright, so if you want to check your answer for this question, what you can do is type in both cubics into the equation solver and get both your roots and compare them. So if it's plus 1, then you know you've done it right. That is kind of long, so it is easier if you have 2 calculators. I would recommend in your exam to have 2 calculators because it actually does make stuff a lot easier, especially for checking. Alright? Okay, so for question 7, we have a curve C which has the equation y equals 4x cubed plus 7x squared plus x plus 11. The point P lies on C where x equals minus 1. Find an equation of the tangent to C at point P. Alright, so if we're asked to work out the tangent, what the tangent basically is if we draw a cubic, now this is probably not what the cubic that we're told it looks like, but if we have a cubic like this, for example, the tangent is a straight line that crosses through the curve at one point. Okay? Now, to work this out, we need to work out the gradient at this point of the curve. So the gradient we can work out by differentiating the equation. So we get dy by dx equals, and now we sub in minus 1 and we get, alright, so now we have the gradient of this line here. Now we just need a coordinate to find out the equation. Now we're told one point is x equals minus 1, right? And that's where this point is. And we have the equation of the curve. okay, which also goes through that point. So we can just sub in x equals -1 into that equation, and we get -1 13, and we can sub that in to get our equation of the straight line, so that we get, alright, and now I'm going to rearrange this to get, okay, so our equation of the tangent is y equals -x plus 12. Now onto part B. So we're told that the tangent to C at P meets C again at Q. Determine the x coordinate of Q. Now, essentially, what this means is, if this is the curve, the tangent is only the tangent to the curve at one point. Okay, so, as in, it only has the same gradient as the curve at one specific point. Here, it can intercept again, but here they have different gradients. Okay, at this exact point they have the same gradient. Here, we can't use the information of differentiating. Okay, however, we do have the equation of the tangent, which is -x plus 12, and we also do have the equation of the curve. And from here I can set them both equal to each other to get, and if I type this into the equation solver, I get, okay, so I get x equals -1 and x equals 0.25. Now, the point x equals -1 refers to our point over here. However, x equals 0.25 refers to this point over here. Okay, now our graph isn't obviously drawn to scale, but it's good enough for what we need. So we know that the point of Q, the x coordinate is 0.25, and that's our final answer. Alright, so for question 8 we have a quadratic curve which has the equation f of x is equal to 12x squared plus 4x minus 161, and we need to express this equation as the product of two linear factors, which essentially just means something like ax plus b cx plus d. Okay, so we can do the GCSE way, where we just find out two numbers that multiply and two numbers that add together. However, I think that the easiest way to do it is by solving it, because these are quite big numbers, right? So I think solving it and then rewriting it is the easiest way. So I'm going to show you what I mean by that. So if we solve it, we can use the quadratic equation, or we can also just use, oh actually no, it says a detailed method, so yeah, I'm actually going to solve it. So okay, so we need to solve it, we can use the equation minus b plus or minus square root b squared minus 4ac all over 2a, and if I sub in those values I get, okay, and now what I can do is I'm going to focus on this side first. So here, if I want to write it in terms of ax plus b equals 0, I can just times by 2 and I get 2x equals 7, and I'm going to take away 7 to get 2x minus 7, and this equals 0. And in here, if I want to do the same, I can do 6x equals minus 23, 6x plus 23 equals 0. And now this should be our two factors. However, you should check just in case, as you may need to, like for example, times this whole thing by 2, or just times one of them by 2 or something. So if we expand and simplify, we get 12x squared firstly, and to be honest, that's all we need to do, because 12, okay, so we know that the factor is right. Okay, we don't need to multiply any of them by 2 or anything. Okay, it's perfectly right. So I'm just going to finish off by rewriting it as f of x equals 2x minus 7, 6x plus 23. Okay, Alright, so for question 9, we need to show that if x is numerically small, 2x plus x minus x squared all to the power of 5 is equal to ax plus bx plus cx cubed, where a, b and c are integers to be found. Now, essentially, if we expand and simplify this, we should get some long equation, and the highest power we'd expect is a power of 10, because we have a 2 and a 5 here. Now, instead of expanding and simplifying the whole thing, we can just do binomial expansion. However, we would still get, a bunch of powers that we don't need. So to counter this, we can stop when we get x cubed. So it requires a lot of algebraic manipulation and like thinking what we're gonna get. So I'm gonna go by this step by step. So firstly, I'm gonna think about what the coefficients are with binomial expansion. So it's 5 choose 0, 5 choose 1, 5 choose 2, so on and so on. So that's 1, 5, 10, 10, 5, 1. Okay, so here are my coefficients for the choose function. Now, to make this simpler, what I'm going to do is I'm going to consider this as one term, okay, x minus x squared, and I'm going to consider 2 as another term. Alright, now when we start off our expanding and simplifying, we start off with 2 to the power 5, okay, and then we go down gradually. 2 to the power 5, 2 to the power 4, 2 to the power 3, and in terms of our x minus x squared, we would start off with x minus x squared to the power of 0, x to the minus x squared to the power of 4, and now hold on, so at this point here, what you need to realize is, so they've stopped at x cubed, right? And so in each of these terms, we get a power equal to or below x cubed. So for here, for example, we get no power because 0. Here we would get an x term, and we would get a 2 term, right? A squared. Here we'd get a squared. We'd also get an x to the power 4, which is relevant. We don't need that. We also might get a cubic. We probably would get a cubic. Here we'd get an x cubed term that we do want. We get an x to the power 5 term, which we don't want. We'd also probably get a power to the 4, which we don't really care about, and also a power to the 6, which we don't really care about. So here we get a power to the 4, and that's our lowest term, so we don't really need that. So essentially we can just stop about here, and then what I can say is 2 plus x minus x squared to the power 5 is equal to 2 to the power 5. Now this just equals 1, so I can just leave that, plus 5 times 2 to the power 4 plus x minus x squared, right? And that's this whole term, plus 10 times 2 cubed plus x minus x squared all squared. I'm going to square that now just to make it simpler. So we get, and then we get plus 10 to the power of 2 squared times, okay, so now we should do binomial expansion on this bit. So we'd get x cubed minus 3, actually, to make this simpler, what I'm going to do is I'm going to rewrite this as x cubed 1 minus x cubed, okay? So I've basically just taken out a factor of x cubed, and that makes our job a lot easier, since all I need to now do is do binomial expansion for this, which is a lot easier since it's just 1 minus 3x squared plus, no sorry, minus 3x plus 3x squared minus x cubed. But also, so what you think is we're going to times this whole thing by x cubed, and once you do that, so we get x cubed here, and then we get x to the power 4, and we don't really need that. So essentially we can just rub this whole thing out because we don't really need it. And then from here we can simplify this whole thing as this, and if I simplify this I get the equation. So that's our final equation, and I'm just going to write a equals 32, b equals 80, c equals minus 120. Okay, now for question 10 we're told f of x is equal to x to the power 4 minus 4x. Part A, we need to find a simplified expression for f of 2 plus h minus f of 2. So essentially we just need to sub in 2 plus h first into the equation, minus 4 2 plus h, and then we need to take away f of 2, which is just I'm actually going to just work that out now. So that is, and now I just need to take away 8 from this, and now all I need to do is expand and simplify everything. Now to do binomial expansion of 4, what I normally recommend is do something like this. So this is my way of doing it. So I write the coefficients first. So if it's to the power 4, the coefficients are 1, 4, 6, 4, 1. And then since it's 2 as the first term, I'm going to start with 2. So we go 2 to the power 4, 2 to the power 3, 2 to the power 2, 2 to the power 1, 2 to the power 0. I'm just going to type in the actual thing. So 2 to the power 4 is 16. And then I need to type in, or I need to write the h, which is h to the power 0, which is just 1, h squared, h cubed, and then h to the power 4, right? And now these are all my terms, and then I can just collect them all together and multiply them. So we get 16 plus 32h plus 24h squared plus 8h cubed plus h to the power 4. Okay? And then, so that is just equal to that. And then I need to focus on the next bit, which is just the 16's cancelling out. Okay, so for part B, I need to use the formal definition of the derivative as a limit to show that the derivative of f of x when x equals 2 is equal to 28. Okay, so essentially what they're saying is differentiate it with first principles and sub in when x equals 2. So if I do that, I get, and so we need to do this for when x equals 2, like they've told us. So I'm just going to sub in x equals 2. And luckily for us, in part A, we worked out this same expression. So I can just sub that in, and I get, which I can also simplify down to, alright, and as h approaches 0, we get that this whole expression is equal to, therefore, the derivative of f of x when x equals 2 is equal to 28. Okay? Okay, so for question 11, we need to find, without the use of any calculating aid, the solution of the equation half times 4 to 2x equals 64 to the power of 64. Alright, now this is a quite challenging question. Now, the first thing I think of is 2 and a half and 4, they're both things that I can write in terms of 2 to the power of something, and so is 64. So I'm going to do that now. So I'm going to write I'm going to write a half as 2 to the power of -1. I'm going to write 4 to the power of 2x as 2 squared to the power of 2x, and I'm going to write 64 to the power of 64 as... Alright, so from here I'm just going to combine this power in the brackets, and then from here what I can do is add these powers, so I get 2 to the power of 64 times 6, 2 to the power of 4x minus 1 equals 2 to the power of 384, and then what I can say is 4x minus 1 equals 384, 4x equals 385, and then x equals 385 all over 4, right? The fact that they've said without the use of any calculating aid makes it kind of... It gives off the assumption that you're not allowed to use a calculator, which is far from true. I think what they essentially just mean is, if you have a calculator that can solve this straight away, don't use that. Show the steps, essentially. Alright, now for question 12, we're given a closed cylinder can of radius r and height h. Now we're asked, if the volume of the can is 330 centimeters cubed, show that the surface area of the can, a centimeters squared, is given by a equals 2 pi r squared plus 660 over r. Alright, so to answer these questions, we normally need to use the formulas for the volume of the cylinder, or whatever shape it is. In this case we have a cylinder, and the surface area of the shape, okay? Alright, so now that we've got our two formulas, we're going to compare these formulas to this equation. And if you look carefully, you might notice that there's no v in this final answer, and there's also no h in the final answer. So essentially, what we can do is, well, we know that the volume is 330 centimeters cubed, so we can sub in that for v, and we get... And from here we know that there's no h, so what we can do is make h the subject of the formula, so that we get... And from here we can sub in this h into here, so that we get... And you can simplify this to... And now we've shown that the surface area of the can be represented by 2 pi r squared plus 660 over r. So that's part A done. For part B, we need to find the value of r for which a is stationary. Now to do this, we need to find the derivative of a in terms of r. So we need to find dA over dr. And when we derive a, we get... Now, the reason why we do this is we know that when a is stationary, dA by dr is equal to 0. Okay? So now we can let this equal 0 as well, so that we get... And now we just need to solve for r to get 3.745. Now for part C, we need to justify that this value of r that we found in part B gives us the minimum value for a. Now to do this, we need to find the second derivative. And now we just need to sub in our value of r into this equation, so that we get... Now obviously this is greater than 0, therefore it gives us a minimum value. Alright, and lastly for part D, we need to calculate the minimum value of a. So to do this, we just sub in the value of r into the original expression here, so that we get... Okay, and that's 12D done. Alright, so question 13 involves solving simultaneous equations involving logs. Now you probably haven't seen anything like this before, which is why I think practicing Madas maths questions is really important, because it just pushes your knowledge further. So to start this, what I would say is, normally what I like to do, leave everything in terms of log something, as in, so if it has a coefficient, bring that coefficient up into the power, which you know you can do as log rules, like this. And then also bring all the logs to one side. Okay, so I'm just gonna do that there. I'm gonna do that now so that I get. Alright, you should also know that from your log laws, you can also rewrite this like this. Now what this means is 2 to the power of 1 equals y minus 1 over x. So this means, okay, and now I'm going to times both sides by x and add 1 to both sides to get, alright, and now if I do the same for the second equation, I get, and if I get them both on the same side, I get, and using our log laws, I can rewrite this as, now what this means is 3 to the power of 2 is equal to y squared over x, so that we get, okay, now from here I'm going to make y squared the subject of the formula, so I get, now the reason I did this is so that I can sub in this into here, so that I get, and now all I need to do is solve for x, so that I get, and now to get y, I just sub in these values into the equation 2x plus 1 equals y, so that I get, and now our solutions are, alright, so that's the whole paper done. Subscribe and like if you enjoyed the video, and comment down below what paper you guys want me to go through next.